Each year, the brightest science fair projects from schools across Canada gather for national competition. During this year's Canada-wide Science Fair, 4 students receive special honors, the coveted Young Canadian Innovation Awards.
I think that a science project is one of the best ways to introduce yourself to science, doing your own experiments and research. And it helps you develop a curiosity about nature.
It's important not to get discouraged and to keep on working at it because you're passionate about it.
Everything around us is science. Everything you do in your everyday life is basically science. Even what you think, what you feel is science.
Kids should stick with science because it's the way of the future. We're developing all the technologies that will be important to us later on in life.
If kids don't develop an interest in science, I think we'd be somewhere around the Stone Age.
My name is Spencer Hughes, and I'm from Timmins, Ontario. My project is titled LED Squared Mining, a thermoionic bioreactor.
Hoping to revitalize his hometown economy, Spencer Hughes developed a set of experiments to make electricity and reclaim heat and gold ore from the polluted waters that occupy abandoned underground mines.
Where I'm from, it's Timmins, Ontario, and we have a large problem with sinkholes and pollution caused by little bacteria or bugs within the mine. So I wanted to find a way to solve those problems while at the same time generating money and power for the community. I'm basically going to take those little bacteria that are floating around right now, and what they do is they eat iron pyrite, and that's called fool's gold, which is also associated with real gold. It's found together. So as they're eating their fool's gold, they're actually absorbing the gold as well. So using special types of processes, we were able to recover that gold, while at the same time harnessing the bacteria's energy system, and we're able to get electricity from them. So as well, there's a hydroelectric component, just like at Niagara Falls. So we're going to use the falling action of water going down the mine shaft to generate electricity. And as well, we're going to get heat from the water because there's lots of energy being put into the water by the earth. So we're just going to extract that using heat exchanger units. As well, it eliminates the pollution caused by our abandoned mines. So we beautify the area, we generate money and energy for everybody. I'd like to leave my legacy on Timmins. I just want to help out my community.
My name is Carol Barfett. I'm from London, Ontario, and my project is entitled Artificial Cells as a Feed Additive for Pollution Control in Aquaculture.
As a child, Cara Barfett experienced the pollution problem associated with aquaculture right in her own aquarium. Cara's curiosity to find a solution led to her award-winning science project.
Fish farming, or aquaculture, is a very popular and expanding industry in Canada and around the world. There are many benefits to this industry, but also when you begin introducing large quantities of any species into an aquatic environment, you're going to see a pollution explosion. Right now, there's no way of dealing with this pollution because you can't use an industrial filter in that kind of setting. What I've done is I've created a fish feed additive that will actually convert harmful chemical pollutants while inside the digestive systems of most aquatic animals, and actually many mammalian species as well that are also used in aquaculture. Also, my technology is extremely inexpensive. I ran about 4 years of tests on about 4 cents of products, so it's making this industry much more accessible for Indigenous peoples in North America and South America, as well as for many third world countries. I think it's important that I leave my technology behind and that I know that I'm making the world a better place not only for Canadians but for a lot of third world countries, and for the environment that we're going to be handing down to our children.
Hi, my name's Adrian Mailer from Chrysler, Ontario, and my project's called We Got Rhythm.
Normal biological events that repeat every 24 hours are called circadian rhythms. Adrian Mailer has developed a series of mathematical equations to help scientists predict how outside influences might affect human circadian rhythms.
I've taken a look at the circadian clock, which is a time-keeping organ in the human brain. I've tried to develop a system of equations to model that so we can predict the effects of, say, pharmaceuticals like Valium on the circadian clock. For example, our body temperature and some of our hormones are controlled by this clock. And in the society we live in, it's very easy to change our rhythms, for example, through jet lag. And it seemed that there weren't any up-to-date mathematical models that could be used for this type of experimentation. I think it definitely has some applications to space travel because we've seen disrupted and tampered with circadian rhythms in astronauts. Hopefully with some more biological research we can improve the model and develop some more or less foolproof ways to keep astronauts on a normal 24-hour day in space. A lot of time went into it, but I think it was worth it.
My name is Ladiko Barris, and I'm from Windsor, Ontario. and my project is called Go Green, and it's the construction of a bioreporting system for the detection of heavy metal ion contamination.
Growing up in an industrial community, Ildiko Barris realized a lot of heavy metal ion pollution goes unchecked. So Ildiko developed a bioreporting system to help investigators test for heavy metals in soil and water.
Basically what I did was I made a bacteria that will glow green when it comes in contact with heavy metal ion contamination. And I used green fluorescent protein that can be easily detected under ultraviolet light, and metallothionein, which is sensitive to heavy metal ions. And basically I created a plasmid that was transferred into a bacteria, and when it detects heavy metal ions, it glows green. This has never been done before, where GFP has been joined to produce a bioreporting system. So it actually has taken a problem and made it simpler to solve. We'll have a test tube full of this bacteria. You can pour the water in, let it incubate for about 2 or 3 hours, test it under UV light, and if you see that it glows, there's heavy metal ions present. If it doesn't glow, there's no heavy metal ions present. It's very hard to regulate heavy metal ion contamination, and I believe these experiments will help the world become more aware of the heavy metal ion pollution that exists in the world. I'm very honored to be a recipient of the Manning Awards.